Hi, this is the continuation of the rules of probability, module 2. In order to understand the addition rules better, we would first require to understand the types of events in detail. Like how we have disjoint sets, mutually exclusive sets in set theory, we also have mutually exclusive events, and based on which the rules of addition differ. So events could be collectively exhaustive, meaning all the events in the sample space combine to form the entire sample space. So in this case of the Venn diagram, event A and event B combine to form the entire of the sample space. Two mutually exclusives are collectively exhaustive, and such events are binary or dichotomous, having only two outcomes. For example, a car repair either covered by warranty or not covered by warranty. So warranty and no warranty constitute the entirety of the sample space. There could be more than two mutual exclusive events to form a collectively exhaustive set. In this case, it is polytomous, meaning there are many possible outcomes A, B, C, D, each having its own category. Let's say, for example, the payments made by customers in a grocery. It could be by credit card, event A, could be by debit card, event B, could be by cash, event C, could be by check, event D. So the entirety of the payment is summed up either by cash, debit card, credit card, or by check. So all payments fall into any one of these categories. Hence, this particular event is collectively exhaustive. Now, when are events mutually exclusive and collectively exhaustive? If the occurrence of any one event means that the other cannot happen, then we say the events to be mutually exclusive. Like, for example, if somebody pays by cash, they would not pay by credit card. So when one happens, the other cannot happen. These are mutually exclusive events. Events are collectively exhaustive if at least one of the events would occur when you conduct the experiment. It implies that when somebody makes a payment, they make the payment through any one of these following modes, and nobody leaves without a payment. Thus, the experiment of making the payment will result in any one of the outcomes. They are called as collectively exhaustive. Mutually exclusive events are also in the form of disjoint sets. So the intersection of the sets is null set. There is nothing in common between the two sets. So A into intersection B in this case would be a null set or zero, no elements. This leads to a special law of addition. When events are mutually exclusive, the law states or reduces to P of A plus P of B. So A union B, in other terms, A or B will be probability of A plus the probability of B. Union, represented in a Venn diagram, is the combination of all elements in both these sets, A union B. So the general law of addition states that the probability of two events A and B is given by the formula P of A or B equal P of A plus P of B minus P of A and B. When you add the probabilities of A and B, we actually add and count the common points two times. That is P of A. This is P of B. So when we add A and B together, we add this part, the common point, two times. And hence, it needs to be deducted one time. That is why the formula remains to be P of A plus P of B minus P of A and B. Otherwise, the probability would be overstated or sometimes could become exceeding more than 1. Let's look at an example for the general law of addition. For example, a fair pack of cards. Now, what's the probability of getting a queen? There are 4 queens in a deck, so 4 of 52 cards. What's the probability of getting a red card? There are 26 red cards of 52. Now, the probability of having a queen which is also red. So there are 2 red queens in a deck. So if we were to find the probability of getting a queen or a red card, we would be adding queen once and the red once. But the red queen, which is the common point between queen and red, is added 2 times. Once when you add the queens, once when you add the red cards. So that needs to be deducted. That's P of Q intersection R. So that's 4 out of 52 plus 26 of 52 less 2 of 52. That's 53.85%. So a summary of the rules of addition. The special rule of addition is when the events are mutually exclusive. The rule becomes P of A or B equal P of A plus P of B. The general rule is always that you add the probabilities P of A plus P of B and less the common point. The common point needs to be subtracted because the events are not mutually exclusive, meaning they can happen at the same time. Another example for us to understand mutually exclusive events with the same package industry. So what's the probability that you get a package which is underweight or overweight? Now here the events are mutually exclusive because a package can fall in any one of these 3 categories. Hence P of A or C equal P of A plus P of C. That's 0.025 plus 0.075 equal 0.1. It's 10%. Now when events are not mutually exclusive, let's take a small example, like the cards example. What's the probability of getting a king or a heart? So the probability of A is defined as getting a king. There are 4 kings of 52 cards, and probability of getting a heart. There are only 13 hearts card in the deck of 52, so 13 of 52, and a king of hearts is only 1. So P of A or B equal P of A plus P of B minus P of A and B. So that's 4 of 52 plus 13 of 52 minus 1 of 52. That gives about 30%. So when we look at addition rule, we need to check whether the events are mutually exclusive or not. If the events are not mutually exclusive, like in the case of a cards where you can have a king which is also of the heart symbol, which means both king and heart happen at the same time, they are called as joint probabilities. For example, you visit a particular place and you could probably visit the Disneyland or the Bush. So then there are people who could visit both of them. That's the joint probability of visiting Disneyland and Bush. Thank you for watching this. Let's continue with the next module, which would be on conditional probability.